projection of solids. You have studied the concepts related to projection of planes. The concept remains the same in the projection of planes you were studying with respect to You were studying the planes with respect to the laminas which had negligible thickness. But here in case of projection of solids, we will be dealing with three-dimensional objects. So you should be thorough with the concepts, how it looks like. So let us start up with the basic concepts of projection of solids. Okay, I will just share a PPT of mine. Is the PPT visible for everyone? Hello? Kindly reply, is it visible to everyone?
Yes,
okay, thank you. So we will be dealing with the concepts of projection of solids. So everyone knows a solid is a three-dimensional object. In case of planes, we had only plane surface with negligible thickness. Only the laminas we were understanding with respect to HP, with respect to VP, and we used to solve the problem with three stages. Similarly, here also, here also we do study the position of the front view and the top view with respect to three stages. But we have certain protocols, certain rules and norms what you have to follow. So before that, you should understand what you mean by a solid object. So a solid is a three-dimensional object, so which will be having all the three aspects, that is the length, breadth and thickness. And these three constraints will be bounded either by a plane or a curved surface. If it is a plane, it will be a rectangular plane surface which bounds to get a solid, or if it is a curve, means you will be having a triangular lamina which will be turned 360-degree round to get the required solids. I will explain you what all it is. So basically, you should understand a solid is a three-dimensional object which has length, breadth and thickness, all the three. So later you should come to know about the types of solids, the classifications, which type of solids we will be dealing with. Okay, so there are three categories. Mainly these are classified into prisms, pyramids and solids of revolution. So we have main three classifications. So related to all these classifications, we are supposed to solve the problem in projection of solid. So kindly understand properly. Okay, so related to that, we will speak about prism. So what do you mean by a prism? I told you the prism, irrespective of any solid, it will be bounded by a plane or a curved surface. So you first understand that. So in case of prism, you will be having a top surface and a bottom surface, which will be made of same shape. Okay, but these top and bottom surface will be bounded by rectangular plane surfaces. So in this prism, you will be having three rectangular surfaces, 1, 2, and another one is on the back side. So these two surfaces of triangular lamina will be bounded by three rectangular surface. Then only it results in the formation of a three-dimensional object. Since it is triangular lamina bounded, we call that to be as triangular prism. So next is our square prism. So how does a square prism looks like? A square prism will be having a square lamina at the bottom and a square lamina at the top, or else you can call it as a square surface at the top and square surface at the bottom. So these two surfaces will be bounded with the help of rectangular surface. So this is one rectangular surface, this is one rectangular surface. Here you will be having one rectangular surface backside, and here you will be having one rectangular surface backside. So these two are hidden. So totally you will be having four rectangular surfaces which bounds the top square surface and the bottom square surface. So this is how a square prism looks like. So next category what you have to understand is our pentagonal prism. So how does it look? A pentagonal prism will be having a bottom surface and a top surface. So bottom pentagonal surface and a top. And these two will also be bounded by using rectangular surfaces. So here the prism will be bounded with the help of 5 rectangular surfaces. You can see 3 here. 1, 2 and 3. On the back side, you will be having the fourth one, and this side also you'll be having one, which is fifth. Okay, so totally it will be bounded by 5 rectangular surfaces, and hence this is called as our pentagonal prism. So next comes our hexagonal prism. Same thing. Hexagon, you know it will be having 6 sides. So you'll be having one bottom surface of hexagonal surface and one top surface, again an hexagonal lamina. So these two will be bounded again by the rectangular surfaces. Since it is hexagon, you will be having 6 rectangular surfaces. 3 here, fourth one, fifth one and sixth one. These 3 sides are hidden. So this is how a prism looks like. And if they tell a triangular prism, this image has to come in your mind, which object you are using. If they tell in the problem it is a square prism, this object should be visualized. If they tell a pentagonal prism, you should visualize this image. And if they say it is an hexagonal prism, then this image should come. Suppose if you have this and it is told, and every prism or the pyramid, they'll be having a central axis. So how you draw a center axis? At the top, you'll be having a center. So if you join the diagonals, you'll get a center point. And similarly, if you join the diagonals, you'll get a center point. So you will be having a central axis from the top to the bottom. Always we use the concept of axis is perpendicular, axis is inclined to HP and VP. Then you should understand what you mean by axis. Axis is nothing but it won't be visible, but it will be acting right from the center of the top to the center of the bottom surface. Here also in pentagon, if you join the diagonals, either two, if you join, you'll get the center point. So from the top to the bottom, you will be having an axis. Okay, so this is called as the axis. Here also in the square, if you join the diagonal, you'll get the center point at the top. Similarly, the bottom. I know how I have told you how the axis line should look like in the beginning class. Similarly, you will draw an axis line here. Since a three-dimensional object, axis will not be visible, it will be hidden. It will be in the center. Okay, similarly here also. Okay, the axis, if you join two medians together, you will get one axis from there to the bottom. And here the axis has been overlapped with one of the side. Okay, so this is how you should be knowing about the classification of the prism and the axis also. Next, you should know what you mean by pyramids. Okay, similar to prisms, pyramids also we have in our projection of solids. So by looking in the diagram, what do you understand? You can see a base here in each diagram and a common point where it has been joining. So what is the difference you will realize? In prism, you will be having top and bottom surface of same area, same cross section. It is not like you have triangle here and square here. Same lamina only you have with respect to same dimensions. But here in case of pyramids, you will be having the base surface only. The top will be joined at a common point, what we call as an apex. And one more thing what you have to understand here is, in case of pyramids, the given base surface is bounded with the help of triangular surface. Whereas in case of prism, it was bounded using rectangular surfaces, and hence you got the same area of cross section of the base at the bottom as well as the top. But here it is not the case. You'll be having only one base. In this case, it is, and triangular lamina is the base. It is bounded by triangular surfaces. So how many faces you have? 1, 2, and other one is 3. So triangular pyramid is bounded by 3 triangular surfaces. So a triangular pyramid will be having a common base, which is the triangular base, and a common point where all it meets. So this is our apex. So this is called triangular pyramid. In case of square pyramid, you will be having a square base that will be bounded by 4 triangular surfaces, 1, 2, 3 and 4 backside. So all the 4 triangular bases will be meeting at a common point which looks like a pyramid, hence the name pyramid. So the common point will be called as our apex. So this is our square pyramid. And again, pentagonal pyramid will be having a pentagonal surface at the bottom and you will be having a common point called apex. So this will be bounded by 5 triangular surfaces which meets at a common point which will be our apex. Similarly, in hexagonal pyramid, you will be having an hexagonal surface at the bottom which is called to be as the base of the pyramid. It will be bounded by 6 triangular surfaces. So all these 6 triangular surfaces meet at a common point, what we call it as an hexagonal pyramid. Even in each of the pyramid, you will be having an axis. So from the apex to the center of the base surface, you will be having the axis. In case of triangular, even if you join 2 diagonals of the square, you will get the center point. From there, you have to join to the apex. So that will provide us the axis of the square pyramid. Similarly, in pentagonal pyramid, you will be having the entire pentagonal surface and a center point. So if you join 2 of the bisectors, you will get a common point. From there, if you join above to the apex, you will get the axis. Similarly, in hexagonal, if you join 2 diagonals here, from the center to the apex, you will get the axis. This is about pyramids. So I hope you're clear with respect to prisms and pyramids. You have to solve problems with respect to each category of prisms. Similarly, with respect to each category of pyramids also. And then there is a last type of classification, what we call it as center of revolution. So what do you mean by this? By means of center of revolution, we have 2 solid objects. One is called as a cylinder, another one is called as our cone. So what do you mean by the term solid of revolution? So here a given surface will be revolved 360 degree to trace out a cylinder. So how that is possible? Okay, so you can just have an axis here. Okay, suppose if you have an axis, so you just draw an reference axis and you just use an rectangular lamina. Okay, so you have a rectangular lamina along with an axis. So if you make this rectangular lamina to rotate 360 degree around, then it traces a circular path. So here you will be having initially the rectangular lamina and you will rotate this rectangular lamina 360 degree. So then it traces out a cylindrical curvature. So this yields in forming our object called cylinder. Okay, similar, and hence it is revolved around 360 degree. It is called as solid of revolution. The same concept has been applied for our cone. What happens here? Here also you will be having a common axis. At the common axis, so this is our axis. So at the common axis, what you will do? You will trace out a triangular lamina 360 degree. So how do you do that? So just for your understanding, so if you just create an this is a triangular lamina. So if you just make to rotate this triangular lamina 360 degree around the axis, then it helps in tracing out a cone-like structure. So this is called to be as our cone. Since it is revolved, you call it as a category under solids of revolution. You can get problems again on cylinder as well as cone. So both these comes into the category of solids of revolution. So this is about the classification of solids. Then you should know about different parameters associated related to solid, because they keep on telling the corner, the edge, the slant edge, the generator of a solid. So then you get confused. What do you mean by it exactly? So you should be knowing some dimensional parameters associated to different solids. So we studied all these now. Square prism. I have taken only one example for prism category, one example for pyramid, and under solid of revolution we have two categories. I have shown it. So if we come to our square prism, you know how a square prism looks like. So you'll be having a bottom and a top surface, and it will be bounded by rectangular surfaces, I told you, right? So if they tell a rectangular face in case of a square prism, you should be able to identify which is the rectangular face, okay? And if they tell you as a base, you should be able to identify this is the base of the square surface. If they tell you the top of the square prism has been inclined, yeah, whatever, then you should be identify which part they are telling. So this is the top of the square prism. This is the bottom of the square prism. Along with that, if they tell it is inclined across a particular edge of the bottom, so or the base, then you should be able to identify which is the edge of the base. So this is the base. So all these sides are called as the edge of the base. Either the side or the edge, it remains the meaning is the same. You have to show this part as the edge of the base. Suppose if they tell you the corner of the base, then these points are called as the corner of the base of the square prism. So you call this as corner of the base. Similarly, if they speak about the top of the square prism, this is the top. If they speak about the edge of the top, then you have to show these are the edges. If they tell you the corner of the top surface, then these are the corners, 1, 2, 3, and 4. Okay, so these are edges, and if they specify as longer edge, then you should be able to show these are the longer edge or the side, longer side or longer edge, because compared to the edges here at the bottom and the top, these edges are longer, and hence you call this as the longer edge. So this is applicable with respect to all the prisms. Okay, so every prism will be having a base and a top. It will be having a longer edge because it is traced by a rectangular surface. Okay, so this remains the same. Only the number of corners get changed as you go to pentagon and hexagon as 5 and 6, but the wordings remains the same. So next comes to our square pyramid. What happens in square pyramid? Everyone knows you have only one common base and those are bounded by triangular surface. So the point at the top is always referred to be as the apex. I told you already. So this is called as the base of the square pyramid. If they tell base, you should be identify which is there. So this is the base of the square pyramid. And if they tell you the triangular surface, this is a triangular surface. 1, 2, and other one in the back side. And here you won't get a longer edge. You will get a slant edge because you have an inclined side over here, not a perpendicular line. Only you get a perpendicular line in case of prisms. In case of pyramid, always it is inclined and hence you get a slant side only. So in the problem, they can justify as a slant side or slant edge. Both remains the same. And again, if they tell just the edge, and then these are the sides what they are speaking about. So edge always will be associated with the base. Only if they tell slant edge, then these are the edges what you have to take care. So this is similar for all case of pyramids, whether it is square pyramid, pentagon, hexagon, or triangular pyramid, the terminologies remains the same. And then under our solids of revolution, we have two categories. One is our cylinder and other one is the cone. So I've told you how a cylinder and cone is formed. So here, when you in a cylinder, you know you'll be having a top surface and a bottom circular surface. So it is framed by a rectangular surface revolving 360 degree. So due to revolution, there will be n number of lines which are traced out across the circumference of the top circle and the circumference of the bottom circle. So these perpendicular lines will be called to be as the generators. These generators will not be visible on the cylinder. These are the imaginary lines. So this is used only to trace out how the rectangular surface has revolved across the surface to get cylindrical object. Similarly, in case of apex, you will be having the generators. Here the generators will be parallel, but here it will be an inclined generators what we get. So this is only the difference between the cylinder and a cone, where the generators will be parallel and here it will be inclined. So in both the cases, generator shows the path traced by the rectangular surface here. In this case, the triangular surface in case of cone and rectangular surface in case of cylinder. So tracing out path will be shown. And next, this is the second part of the solids. By looking the image, what do you understand? So this is a cone, right? So this is a cylinder and this is a square pyramid. But it is showing an half position of it. Why? So given cone is now cut out into a particular part. So upper part of the cone is been cut. And here the upper part of the cylinder is been cut. And here the upper part of the pyramid has been cut. Okay, so if this is cut like this in an inclined position, so this is a retained part which has been shown here. So this is a full cylinder. If it is cut inclinedly, so this is the remaining part of the cylinder. And this is a square pyramid. So if it is cut inclinedly at a particular angle, then this is a section. How does it looks like? So now, and hence these are called as section of solids. In case of section of solids, an cutting plane will be used which will cut at a particular angle and it won't cut parallel across the base of the solid, and hence you will be having some inclined cross-sectional area at the top and the bottom. So you can see at the bottom you will be having a full circular base, and at the top it is not parallelly cut. If it is parallelly cut, you will be having in this way. So both will be concentric, only the area of the circle at the top will be lesser and it will be more at the bottom, actual one. But if it is cut inclinedly, then the position itself get changed. So if it is cut inclinedly, then you call it as a section of a cone. In this you call it as a section of a cylinder. In this case you call it as a section of a square pyramid. Okay. And suppose the given solid object is being cut parallelly across the base surface, then you call that as a frustum of a given solid. So this is a square pyramid. So here the cutting plane has cut the solid parallelly across the base surface. So you can see the alignment, the position will be similar at the bottom and the top. Since it is a pyramid, you won't be getting uniform area at the top and bottom because it is inclined to particular point to get the pyramid point, apex. And as a result, the area at the top and the area at the bottom will not be same. And hence this is called as a frustum of a square pyramid. So this is actual square pyramid. So if it is cut parallelly, then you will get a small square surface at the top and the actual square surface at the bottom. And hence, if they ask you in the question frustum of a square pyramid, so then this is the image what you have to figure out. Please remember, these all concepts are very important in case of projection of solid as well as when you go for isometric projection. So next module is our isometric projection. So where you will sketch out the three-dimensional object in a single shot. In that case, you will use this frustum of a cone, pyramid very frequently. So you should understand what you mean by it very carefully. So next is frustum of a pyramid. So frustum of a cone this is. So you can see the actual cone, how does it looks like. So if it has been cut parallelly to the base, Then due to this part is been removed, so you will find a small circular surface at the top and an actual circular surface at the bottom. Since it is cut parallelly, you call
Ma'am,
this as, hello?
ma'am, I'm having a doubt, ma'am.
Yes, please tell me.
Ma'am, that first term is applicable for prism also.
Yeah, prism also you can, but actually this comes across in case of pyramids only. Why? Because if you cut a prism exactly half, the area at the top and the area at the bottom, area where you get will be the same. Only thing the longer edge get varied. The cross section of the top and the bottom surface
Ma'am,
remains the same.
yes,
And hence we don't use that. Okay, but the concept you can apply for prism also. Done?
yes, yes, ma'am.
Yeah. So this is about the frustum of the cone and pyramid. So this is entire concept related to all the type of solids what we will be using to solve the problem, and these concepts are helpful in our isometric projection also. So then you should be knowing something about the position of the given object. So how it will be rested. In case of projection of plane lamina, we used to tell the corner is being resting at HP. One of the side is resting at HP. Similarly, one of the corner is resting in VP. One of the side is resting in VP. Now you know how to start up with the problem with respect to the given constraints. Similarly, in case of projection of solids, you should be thorough how the position looks like with respect to the given constraints. In that, you should understand few positions. One is the simple position. We have three categories. The first is the simple position. So the axis, I told you what do you mean by an axis. Every solid object will be an axis. Suppose in the given problem, if it is told the axis is perpendicular to HP or VP, what you will assume? See, the axis cannot be perpendicular to HP or VP in a single problem. You can get the problem with axis perpendicular to HP or axis perpendicular to VP. One more thing I'll tell you. In your syllabus, you have all the problems related to axis perpendicular to HP. Related to VP, you don't have in the syllabus. But I'm telling you both the things. So when it is told axis is perpendicular to HP, always we assume that axis is parallel to HP. Similarly, if they tell you axis is perpendicular to VP, always you have to assume that axis is parallel to VP. So this is for simple position. And that category, I'm telling you three types. So first is projection of the solid with axis perpendicular to HP. What happens will give the true shape and the size of the base in HP only. So what did you understand? Suppose if I show you, and I have shown in the video, if it is told the axis is perpendicular to VP, so this will be our horizontal plane, so this will be our vertical plane. So if they tell about it, this is the square prism. How does it look like? A square prism has a top surface and a bottom surface. So from the center of the top surface to the center of the bottom surface, axis will be there, which is not visible. It will be hidden. So if this axis has to be perpendicular to HP, so you have to keep our HP and VP and place exactly vertical such that the axis will be perpendicular to our horizontal plane. So when this axis is perpendicular to horizontal plane, and when you view from the top, how you look like, you can just see a square base. So you have a square surface at the top and the bottom. So the true image of the square base will be visible in our top view. So that is being told. And similarly, when you view from the front, so you will just be seeing, and when you view from the front, you'll just see an rectangular lamina. So this rectangular lamina will be focused in our front view. I have displayed this in the YouTube link. Kindly go through it. Okay, that is a thing. So when the axis is perpendicular to HP, the true shape and size of the base will be visible in horizontal plane. And this will be completed in only one step. If it is told axis is perpendicular to HP, you will just draw first the top view. If it is a square prism, you will get a square in the bottom, square in the horizontal plane, which will be our top view, right? And when you extend the projection above, I showed you in the front, it looks like an rectangular surface. So you will be having a rectangular surface at the top, and you will draw XY line, and you will be having a square surface at the bottom. This will be completed in one step. Similarly, when the projection of the solid with axis perpendicular to VP, how does it looks like? Okay, so here, so this is our horizontal and vertical plane. I can just stop presenting and show you exactly. Okay, so this is a vertical, horizontal plane and the vertical plane. So if the axis is perpendicular to the VP, so this is the solid square prism. So now we had kept perpendicular to horizontal. Then now we have to shift the given solid object perpendicular to our vertical plane. So when you view from the front, what happens? You will be seeing the true shape of the base in the front view. Right? And when you view the same thing from the top, you will be seeing a rectangular surface below our XY line. So you get a rectangular surface in HP and a square surface in the VP as our front view. So this will be exactly the reverse what we had in case of inclination with respect to HP. Okay, so in that case, you'll be having the true shape and size of the base in VP, exactly reverse. I'll show you the image later. Okay, so this is a thing. And in the third position, if it is told the axis is parallel to HP as well as VP, in this condition, you won't be getting the true shape of the given solid object in the front view or the top view, but you will be getting the true shape only in the case of our side view. So that you have to keep in mind. If the axis is parallel to both the planes, the true shape of the given solid will be always lying in our side view. If the axis is perpendicular to HP, the true shape and the size of the base will be provided in HP, means in our top view. If the given solid axis is perpendicular to VP, the true shape and size of the base of the given solid will lie in our VP plane. So these are about the simple positions. And next, this is a two-step problem. Okay, so what happens in two-step? It is told the axis is inclined to HP and parallel to VP. So this could be one case. Or else the axis is inclined to VP and parallel to HP. So this could be the second case. In both the stages, it will be on stage 2 problems. You will be having stage 1 and stage 2. You have in your syllabus only with respect to inclination of HP. So I'll stress more related to that. So in case the axis is inclined to HP and parallel to VP, what is the assumption we should follow? Always we will first assume that axis is perpendicular to HP. So when axis is perpendicular to HP, you will start out with the top view and then go for the front view. If it is a square prism, you will be having the true shape of the square as our top view. When you project above, you will be having a rectangular surface as our front view. So you will join the diagonal and trace out the axis and show the axis is perpendicular to HP. Then what you will do, you will draw the projections. First stage is over, and then you will show the axis inclined to a particular angle as told in the question. Then you will shift the right rectangular surface into a particular inclination. Then you take the projection down and show the top view of the second stage. So it will be only a two-stage problem what we do follow. I'll show with a problem you will come to know. I'm just explaining you the concept. And with respect to explanation, the VP HP inclination with the solids also I've shared in the video link. Please go through it. You will get very clear idea. So in the step 2, what happens? That's what I told you. In the first step, you will assume the axis is perpendicular. Then you draw the square as the top view and the rectangular surface as a front view. So in the second step, we will take the inclination with respect to HP. So as we used to leave some space, shift the axis to particular angle as told in the question. Then you will shift the rectangular surface which was perpendicular now to particular angle. Then we will take the projection down and show the top view. So in the second stage, we can show both the top surface and the bottom surface of the square prism. Since the given prism is inclined to particular angle, it helps in visualizing the top and the bottom surface of the solid. So this is the second position. So always we get the problem related to the option when the axis is inclined to both HP and VP. So in this we get 3-stage problem. So when the axis is in both HP and VP, so you can see here, this is an just example. This is an triangular pyramid. Always in the first stage, axis will be assumed to be perpendicular to the axis. In the second stage, we assume the given axis is inclined to particular angle to HP. Then we will show the given angle will be inclined to particular angle to VP. So these are the 3 positions. Only will be shifting the axis. Okay. So in stage 1, when in the question, if it is told the axis is inclined to both HP and VP, first assumption is you will keep the axis perpendicular to HP and draw the projection. In this condition, you will draw the first front view and the first top view. This is done. And in the second step, what we follow is we will always take the axis inclined to HP at the given inclination. Then you will shift the front view which was in upright position. So here the axis is perpendicular and as you'll be having an upright position. So when the axis is inclined to particular angle, you are shifting the entire front view to a particular angle. So when you shift an entire surface into particular angle and trace and take the projection down, it helps to see the bottom surface as well as the top surface in our top view. Okay, so that is the extra part what we get in projection of solids. So first you keep the axis perpendicular. Then in the second step, we follow that axis is inclined to particular angle to HP. So this is the second stage. Make the axis inclined to HP at the required inclination. Then you will redraw the entire front view and the top view. So you'll be getting the second position of the front view and the second position of the top view. So this is the second step what we follow. So after the second step, we have the third step what we do follow. So what we do in third step, we always take the inclination with respect to VP. Okay, so then we will take the inclination with respect to VP. So here the inclination with respect to HP is done, and these are the different positions. Okay, don't focus on it. I'm just showing you the axis. In the first step, the axis will be perpendicular. In the second step, we take the axis inclined to particular angle to HP, and in the third stage, we take the axis inclined to particular angle to VP. Then we shift the entire second stage top view and front view to the third position. So these are the basic steps you have to follow. If it is a first method, always we'll go with the first one. What is that? We will assume the axis is perpendicular to HP and you will draw the top and front view and leave it out. So that is done in the one step. And in the second step, we will be drawing the XY line. First, we will assume the axis perpendicular to HP. You will show the top view and front view. Then you show the inclination with respect to HP. Then you show the front view and the top view. So that is over. So in the third stage, you have to show all the three stages. But the assumption what we made is same. Always axis will be perpendicular to HP in the stage 1. In the stage 2, you keep the axis inclined to HP, trace out the front view and top view. And in stage 3, we assume the inclination with respect to VP and trace out the final front and the top views. So these are the basic steps what you have to follow irrespective of the given solid objects. Okay, so this is just one problem I'll try to brief out. So just kindly go through the question. I will just send the video link for the problem also how to be solved, so don't worry. So now I'm just explaining you the concept. If you go through the video link, you will get a thorough knowledge. So this is a square prism of 35 mm side of base and 65 mm axis length, which rests on HP on one of its edges of the base, which is inclined to VP at 30 degree. So please draw the projection of the prism when the axis is inclined to HP at 45. So this is a given question. So what is it? First you have to understand which prism, which solid is you have to see. So it is a square prism. So it is a square prism of side 35, means the base of the square prism will be 35 mm. And I've told you the axis length is 65, means to say the length of the axis or the length of the solid object is equal to 65 mm. And it is told the axis is resting on HP. So whenever the axis is resting on HP, I told you that always the first procedure, and before going you see that, okay, and what else has been given? They have given the inclination with respect to VP as well as to HP. So which type of condition it is? They have given the position of the solid and they have given the inclination with respect to VP as well as to HP. So you have to trace out all the 3 stages of it. First, you have to understand that. So after understanding, come back to the first sentence. You know how a square prism looks. You will be having a bottom surface as well as a top surface. Right, so now if you see, so this is a square prism which will be having a top surface and a bottom surface. So they have told axis length is 65, means this height of the prism, the square prism is 65 mm and the axis from the center to the bottom, that height is 65 mm what they have told. And since you have the inclination with respect to HP and BP, we have to show all the 3 stages. In that first what we assume, the given axis is perpendicular to HP, right? So in the first option it is perpendicular. Since the problem they have given the description with respect to HP, we assume that the given axis is perpendicular to HP plane. So in that this will be the position what I explained you already. So horizontal and vertical plane. Axis should be perpendicular to HP, means you have to place the square prism in this way such that the axis from the top to the bottom is perpendicular to HP plane. So when you view from the, so in this position, when you view from the top, you can just see a square base. So when you view from the top, you get the true shape of the square base, and hence we draw the square as a top view. Okay. So here we draw the square as a top view. So it is resting on one of its side. It is not told resting on one of its corner. If it is corner, then we have to shift the square in such a way that it position towards the corner. It is a regular square. So what we do is, so you will rest the position of the square. It is shown 35 mm. So you draw a square. Everyone know how to draw a square. Draw the base of 35 mm. Take vertical 90 degree from both the edges, both the corners, then use the compass, keep one end of the compass here, cut an arc of 35 mm, keep one end of the compass here, cut an arc for 35 mm, you got these 2 points joined. So while naming, be careful, you will be having the top surface right? In this prism, in the square prism, you'll be having the top square as well as the bottom square. So when you view from the top naming of the square base will be visible, but the bottom square will not be visible. So the naming what you give for the bottom square should be written in the bracket. The naming what you give for the top surface should be written outside the bracket to show which surface is visible and which surface is hidden. And hence you can see two namings over here, top and the bottom, right? So you will write the top surface is visible. So the top surface is written out A, B, C and D. So the bottom base surface of the square prism will be written as A1. It is not A dash B dash. A dash B dash comes only in our front view. So you will write as A1, B1, C1 and D1. So bottom's base surface will not be visible. Hence you will write it as A1, B1, C1 and D1. And always in projection of solids, remember you should join and identify the center, because it is a problem in which the axis has to be identified. To identify the axis, only the option is you need to join the diagonals. Only when you join the diagonals, you'll come to know the common point O where it meets. Okay, so thus we completed the top view of the first stage and the naming and the dimension and identified the center. So after this, what we have to do, please take the projection above as we used to do in our planes. And after taking the projection above, it is told the axis is of 65 mm. So first only extend the axis line. Axis line should not be a continuous line. Okay, so it will be a long dash and a small dash, long dash and a small dash. Continue until 65 mm is reached. So after you got 65 mm, similarly you extend the projection from both the sides here. Then join. So you will get the front view of the square prism. I showed you front view how it looks. It looks like a rectangular surface. After doing, you have to write the names. So the bottom surface which was hidden will be shown here, and the top square surface which was visible will be shown at the top. So here all are hidden. So when the observer views from down, so B dash and C dash, sorry, B1 and C1, you will write it as B dash and B1 dash and C1 dash. So when the observer views from the bottom, so this B1 will be visible and C1 will be hidden. So you will write it as B1 dash outside and C1 dash within the bracket. Similarly, when the observer views from the bottom, B will be visible and C will be hidden. So you will write the same thing at the top, B dash outside the bracket and C dash within the bracket. And again you will come here. I am naming both the surface together, bottom and top. So when the observer views from here, you have A and A1, you have D and D1. So first we will write for the bottom surface. Bottom surface are the values within the bracket. So when the observer views from here, A1 will be visible, D1 is along the same line which will not be visible. So when it becomes front view, it will be A1 dash and D1 dash. So now for the top surface, so you have A and D. So when the observer views from the bottom, A will be visible and D is along the same line, it won't be visible. So you will write A dash outside and D dash. So we completed the first stage, front view and top view. But don't forget to name the axis. You should do the naming of the axis also. I told you the axis starts from the bottom surface of the square prism to the top surface. So you have to show the axis. So here this is O1 dash. So all the parameters associated to the bottom surface, we name it as A1, B1, C1 and D1. And for the top, we name it as A, B, C and D. Similarly, the center also, it will be O1 and it will be O. But since it is front view, we will add this as O1 dash and O dash. So this is the stage 1. In stage 1, we assume the given axis is perpendicular to HP. Now, what is the second stage? In second stage, we always assume the given axis is inclined to HP. And here, inclination with respect to HP is given. How much? It is 45 degree. So, first you will take an axis of, first you will leave some space and then you will draw an 45-degree line such that the axis is inclined to 45-degree line. After you incline the axis, the entire front view should be shifted to 45 degree. Here the axis was 90 degree. Now you are shifting the front view for 45 degree line. So how will you construct this line? You can please extend. Here it is not being shown, but it could be extended. So you will extend this axis line. Okay, so then you should draw a line such that for this axis line, this line will be exactly perpendicular. So the axis line and this edge will be exactly perpendicular. Okay, so if this has to be 90, if this is 45, obviously this also will be 45 degree. Understood? Based on the given inclination, this is 45 degree. And I told this side should be 90. So if should be 90, if this is 45, so if you subtract 180 degree minus of these two angles, obviously this side also will be 45. So I can directly keep 45 degree line and extend this. After you extend this line, then you measure the distance, how much it is. So you should incline the position such that the corner here will be lying at one point. It should not come below or above. Okay, I'll show you the exact construction in the video link. I'm explaining, kindly understand the concept. So after taking 45 degree line from here, this axis is already traced out. So you know this distance is how much. And from this distance to this, you please measure using the compass. Keep one end of the compass here and you cut an arc. So you got the base now shifted from perpendicular to the 45 degree line. So after that, what you do is this 45 degree line you have. So in this line, you measure the 65 mm, how much it is. Keep one end of the compass here and measure 65 mm and cut an arc. So you got this reference. Similarly, from here, you draw a line parallel to axis line. Draw a line parallel to our axis line. Keep one end of the compass and measure 65 mm, cut an arc. Keep one end of the compass and measure 65 mm, cut an arc. So you got all the 4 points. Please darken it and do the naming as shown in the first stage front view. Don't omit any naming. All the namings written here has to be traced out. Okay, so after you do the renaming for the front view, again the procedure is same. So you will take all the projections from each point. Okay, so you will take all the projection. After taking all the projection, you will extend the projection from our top view also. So while joining and getting the top view, you should be very careful. You should follow some protocol. What is it? Okay, so when the axis was perpendicular, you can see only the bottom surface of the given square prism. But when the axis is inclined, it is helping you to show the bottom base of the square prism as well as the top surface of the square prism also. Is it right? So now first you should understand why it is so. So when it has been inclined, it will be viewed from the top. So when it will be viewed from the top surface will be visible completely. The bottom surface will be visible partially and this edge will not be visible. How you will identify it? I'll explain you. Listen carefully. So after taking the projection down, your first duty is to cover the outer boundary first. The outer boundary will be always visible. Okay, so what you do is please read the locus. You have the locus of C. So this is C, in the bracket it is C dash. B and B dash, sorry, C and C1, B and B1, D and D1, A and A1. Okay, so now you extend the projection. You have extended already. So you start reading the locus. So this is, so now first I am focusing of the bottom surface. Top surface is here, bottom surface is here. I'm reading only the bottom surface. Bottom surface values are the values which are within the bracket. So this is the locus of C1 and locus of C1 dash. It is meeting at this point. Name it immediately as C1. And then come here. Locus of B1 is meeting B1 dash here. So this is our point B1. And locus of A1 is meeting A1 dash. A1 dash is written here. Is meeting A1 dash at this point. So this will be our A1. Locus of D1 is meeting D1 dash at this point. So this is our D1. So we named our bottom square prism. Similarly, we have to name the top surface of a prism, right? So now read the top surface readings. So this is the locus of C is meeting locus of C dash at this point. So name this as C. Then locus of D is meeting D dash at this point. So this is our point D. Then the locus of A is meeting A dash at this point. So this will be our point A. And we have locus of B, which is meeting B dash at this point. So this is our B. Okay, so please name it immediately or else you will get confused. After naming it, your first duty is to join the outer boundary of the square prism. So use a thick pencil, dark pencil and darken it immediately. Don't overwrite and show two lines. Many people are doing that. Darken immediately because outer line, outer side of the solid will be always visible. No side of a given solid could be hidden in the outer side. So please make all the sides dark and thick. So that is over. So before coming to the inner part, you have the axis line here. So please read the locus. So this is the axis of the bottom surface. This is the axis of the top surface. So the axis of the bottom surface, O dash, is meeting O1 at this point. So this is our O1. Similarly, the axis of the top surface, O, is meeting O dash at this point. So this is our O. So we named our axis also. Axis will be like this form. A big line, a small, a big, a small, a big, a small line. So join and show the axis. So now the left part is which side of the top surface is visible and which side of the top surface is not visible. Right. So now here, this is a top view and this is a front view. So if the observer views from the front, so if the observer views from the top here, always what happens, the top surface of the solid will be hidden. Right now, this is vertical. So in the vertical position, when the axis is perpendicular, you can see the entire top surface. When this is inclined to particular surface also, when the observer views from here, this axis is inclined. So now this axis is inclined to particular angle to our XY plane. If this is our XY plane, this has been inclined to particular angle. But when the observer views here from the top surface will be clearly visible. And only the some part of the bottom surface is visible and the rest part of the bottom surface is hidden. So we have to understand which part of the surface is hidden and which part of the surface is visible when the axis is inclined and viewed from the top. Okay, so that's what. So when the observer views here from the top, the outer square surface will be visible. So using the dark pencil, you will dark the outer surface of the square prism. So this entire thing will be visible. So this is done. So after this, when the observer views here from the top, some part of the bottom square is visible and some part is hidden. So how do you identify the part which is being hidden? So the trick is always you see that the corner which is on XY line, so the projection coming through it always will be hidden. So this is the corner which is on XY line. So the corner is A1 dash and D1 dash. So the projection coming through A1 and D1 has to be hidden. It won't be visible. And hence you make this as a hidden line. The dotted line is called as a hidden line, so which shows this side or the edge is not visible when it is viewed from the top, when the axis is inclined to give an angle. Okay, so once you trace out which is hidden, the remaining part you can dark. So this is darkened already. So this was supposed to be darkened, you will dark it. So this completes our second stage, top view as well as the front view. So first stage, axis will be perpendicular. In the second stage, axis will be inclined to HP with respect to given inclination. So when it is inclined, it helps to trace out the top surface as well as the bottom surface of the given solid. It could be a square prism or anything else. Okay, let me explain you the last stage. So in last stage, I told you when the axis is inclined to both HP and VP, we will assume first perpendicular is the axis, second inclined to HP, and third is inclined to VP. But which side is inclined to VP, you have to understand, no? So read the question. What is being told? So the axis 65 mm rests on HP on one of its edges of the base, and the same edge is inclined to our VP, right? So here now which edge we have inclined, which edge was resting in HP? So this is the edge which was resting on HP, right? So the same edge is now, just a second, I'll just read the question. I didn't read exactly. 35 mm side of a base and 65 mm axis length rest on HP on one of its edges of the base, which is inclined to VP at 30 degree. Okay, it is told that first you know that it is resting on HP. So any one of the edge in which it was resting is inclined to VP. So what is being done here? See the problem carefully. So one of the side or the edge on which it was resting is now inclined to 30 degree to VP. So you can take either this side or this side, because in the first stage we take axis perpendicular to HP. In that case, it will be resting on one of the side. So any of the side, read this, HP on one of its edges of the base. So one of the edge of the base is inclined to VP. So here they have taken the side as D of D1, A of A1. So this side or the edge is inclined to VP. Okay, one of the edge they have told, they haven't specified which edge. If they specify the edge properly, then you have to go with the asked edge only, any one of the edge. So they have taken opposite one because this will be convenient, so rather than going for this edge. Okay, so they have taken the opposite edge, D and A. So D of D1, A of A1. So this edge should be now inclined to 30 degree to VP. And here you should think whether you should go with beta angle concept or not. Even in projection of solid, you have beta angle projection. But since the problem is associated with the side, I have told you whether it is lamina or solid, whenever it is with respect to the side, the true length of the side in first stage and the true length of the side in the second stage will remain same. So beta angle won't come into picture. If the axis was supposed to be inclined, then what happens is you have to determine the beta angle, because you'll get the true length of the axis in the first stage. And here, if you measure the axis length, it will be different because it has been inclined to particular angle. You'll get only the apparent length of the axis here, true length here, and hence in that case, it becomes beta angle. Since it is told the given side is inclined to 30 degree to VP, it is just a normal problem without apparent angle determination. So what you do is you will take 30 degree and then you will shift this side on 30 degree line. Always we have to shift the second stage problem to the third stage. So don't worry about the first stage. So this is the side. So you measure this side, how much it is, leave some space. If you usually you won't get enough space, so what you can do is, instead of taking 30 degree directly from XY plane, you can just draw a line parallel to our XY plane, leaving some distance of 1 centimeter or so. Just draw a parallel line. From there, you try to take 30 degrees because you have to solve the entire solid, right? So after taking 30 degree, leave some space. Don't start very near. Leave some space and fix a point. and name that as D1. After you name it as D1, you measure this distance exactly how much it is. On 30-degree line, you cut that distance. Then you will get A1. So now you got the side or the edge on 30-degree. So you have to construct the remaining part of the bottom surface and the top surface along with the height. Right? So how do you construct it? Once you know D1 and A1, just for 5 minutes, I will complete this. Once you know D1 and A1, just draw a perpendicular line. Okay, extend this perpendicular line on both the sides. From this point, draw a perpendicular line, extend it, draw a perpendicular line, extend it such that this will be 90 and this will be 90. After you construct perpendicular line, measure from D1 to see how much it is, cut an arc. And again from A1 to B, how much it is, A1 and B1, how much it is, you cut an arc on the perpendicular line. So you got all the 4 points. So you see which is hidden and which is darkened. Same thing you replicate, second to third. Okay, so you named this as C1 and B1, D1 and A1 you have already named. So remaining part you have to do. So from D, you have extended the perpendicular line here also. So you measure D1 to see how much it is, just cut an arc. And again from A1 to B, how much it is, you cut an arc or make a reference point. So then you will get the side C and B of the top surface. So name that as C and B. You need to get these two. So again from D1 you measure this distance how much it is. Come here and from D1 you cut an arc on the perpendicular line. And again from A1 to A you measure what is the distance is and cut an arc. So you got all the 4 corners of the top surface. So all the 4 corners of the top surface is visible. So dark it using a continuous line. And the axis also. Identify the midpoint of D1 and A1. So from the midpoint, you measure this distance, how much it is, O1. Make a point. And again, identify the midpoint of C and B. From that midpoint, you just measure this from midpoint to O, how much is the distance. Make a reference point. So from that point to this, just draw an axis line. So here shifting this apparent length axis to here. So once you get this problem, once you get the third stage of the top view, you have to extend the projections. Be careful while you get the final stage. Please extend the projection from C1, from the bottom surface, from the top surface, and from the axis also. So projection from C1, projection from B1, projection from B, projection from C, projection from D1, projection from A1, projection from A, and projection from D. After that, also extend the projection from O1 and projection from O. So this is about our top view. Then you extend the projection from the front view also. So projection from A1 dash and D1 dash, projection from O1 dash, projection from B1 dash and C1 dash, projection from B1, C1, projection from O dash, projection from A dash and D dash. After you extend all the projection, please read the namings locus properly. Here C is meeting C1 dash at this point, write it as C1 dash. D1 is meeting D1 dash at this point, write it as D1 dash. B1 is meeting B1 dash at this point, write it as B1 dash. And then you have A1. A1 is meeting A1 dash at this point, so this is A1 dash. So you got the bottom square. Okay, name it and keep it ready. And then go for the top. A and A dash. So you will get A dash. And then the locus of B is meeting B1 dash here. So B dash here. So this is our B dash. And locus of C is meeting C dash over here. So this is our C dash. And locus of D is meeting D dash over here. So this is our D dash. So we named both the top and the bottom surface. Okay, so at the center one we will do it later. So after this, what you have to understand, here we should understand which is visible, which edges are visible and which edges are not visible. Right, so always the method is, this is the hidden line. So the projection coming out through the hidden line will be always hidden in our front view also. So this is an hidden line, right? So when you go here, so the projection, so the side which is joining D1 dash to D dash will be hidden, and it is extended to this. This D1 this D dash is extended to two edges. So even this will become hidden. This is also hidden, and this is also hidden. So these three corners, these three edges will be hidden. So remaining part will be visible. So remaining all the points you can blindly join using dark thick line. So the this part you will make it dark, and this part also you will make it dark, and the vertical height which is slanting here also you will join it carefully. So then you can see the inclined position of the square prism in our final front view. We haven't located our center axis yet. Then you start reading the center axis. So this is O1 and O1 dash. It is meeting at this common point. So name it. And again you come here. O is naming O dash at this point. So make a point. So then you draw the axis line. Okay. So this completes our third stage. So this is a simple problem on square prism. We haven't gone to complicated problem yet. Please understand very carefully, draw a rough sketch for the concept understanding, then trace out with respect to actual measurement. Only practice makes you perfect. So don't think it is difficult. Please clearly understand the concept. Try to solve one problem by your own. You will really understand, and you will have fun in solving projection of solids for sure. Okay, I've just shown one example, and I will share you some videos related to 3 to 4 problems. So kindly practice this and be ready with the problems on Monday class. At least you should be able to solve problems on square prisms, all the varieties. I will share the questions and video with entire description how to solve the problem. You have to solve it in the sketchbook. And after your internals, kindly see that you install the Solid Edge software. You know how to use the tools. You have done it on lines. We have to do it on planes and solids. I can show you one problems on planes and solids as well. Yeah, Jay.
Ma'am, can you send the link again, ma'am? I'm not getting how to do it in laptop.
Which link? Solid Edge software.
Yes, ma'am. Solid Edge software in laptop.
Okay. I will share again. It was given in the last week. I'll share you again. Okay.
Okay.
Yeah, fine. So now, along with that, Jayant, the links for concepts as well as position is also been shared in the Google Classroom. Go through it clearly, everyone, not only Jayant, everyone, before solving the problem. Okay. Am I audible to everyone? Hello?
Yes, ma'am.
Okay, fine. So I think you have classes. It is 10:50 already. I will share the problems in the Google Classroom, what you have to do it, and video links also for that. Kindly do it at the earliest and be ready for Monday class. Okay. So all the best for other internals. When you have your internals, is it scheduled again?
No, ma'am. They did not inform anything.
Okay, there is some problem, I guess. Okay, fine then. Everyone take care.